Well, we've done some examples of finding the volume around the x-axis, around the y-axis, but now we're going to find the volume of something that's rotated around a line that's not the axis, not one of the axes. Okay, so if you look at this problem, it says find the volume of the solid obtained by rotating the region bounded by y equals 1 plus secant of x and y equals 3 about the line y equals 1. So first I drew the region. Secant x is like this, right? So up 1 plus secant x, and it gets cut off somewhere. I still have to figure out where that somewhere is, right? But just for the time being, this is what the kind of picture looks like. And what am I doing with this? It says about the line y equals 1. So this is that line. Usually I draw it in a straight, like a dotted line, so that I can tell the difference between that and the axis. You can use a different color pen or whatever. So what I'm going to be doing is I'm rotating this guy around, but I'm rotating around that line, okay? So you can now imagine taking this and rotating around, and you're going to end up with some kind of ring type shape, right? With this inner part going like this. But it's rotating around this line, so I basically, instead of flopping this over the axis, I'm flopping it over the line y equals 1, right? So it's going to go kind of around like this. Okay, so you see, instead of the axis being the point of symmetry, your symmetry now is around this other line. Okay, now the procedure is going to be the same, right? I'm going to take, in this case, washers, because I have a hole, right? Right, so it's going to look like this. So that's my washer. It's not a great picture. Right? Definitely look in the book for the pictures. Their pictures look much nicer, right? Because they have them professionally done. But you should be able to draw a picture like this to help yourself understand, even if it's not as nice as the ones in the book. Okay? So now what we see here is it's going to be ending up the same way. You're going to take volume as pi times the integral of the outer radius squared minus the inner radius squared. And the thickness, but because we're going around this line, y equals 1, my thickness is the same as around the line y equals 0 to the axis. My thickness is going to be dx. So I want to be integrating with respect to x. So fine. Couple things. So we have to figure out what all these things are. So let's just start with the limits, because the integral is the first thing I see here, right? Okay. So to figure out the limits, I need to figure out what these points are. I need the x values because I'm integrating with respect to x. So I'm just going to let these two things be equal. 1 plus secant of x equals 3. Secant of x equals 2. Secant is 1 over cosine, right? So that would tell me that cosine of x is 1/2. And then it's going to tell me that this is pi over 3, right? Remember our unit circle. This guy is a smaller one, pi over 3. And of course, I can also get negative pi over 3. And in fact, I need both of those, right? Because this point is going to be negative pi over 3, and this point is going to be pi over 3, 3. Okay? So I can take the integral from negative pi over 3 to pi over 3. You can see this is symmetric. So if I want, I could just do 2 times the integral from 0 to pi over 3 also. That's fine. I'm just going to do minus pi over 3 to pi over 3. So that's the first thing. Now the second thing, this is the part that gets a little more confusing sometimes. let's think about what is the outer radius and the inner radius. Because remember, the line now is a different line than the axis, which means that when you're measuring the outer radius, the inner radius, whatever you're measuring it, you're going to be measuring it from the line that you're rotating it around. So the outer radius is actually pretty easy, right? This line was y equals 3. That's just a straight line. This is going to be the outer radius. So you can see that that's 2, or you can just take 3 minus 1, right? So that is not hard to visualize. Now the inner radius is this. Let me see. I'm gonna maybe put this over here. So the inner radius, you're going from your axis of rotation up to this curve, the curve 1 plus secant x. So how are you going to figure that out? This y is measured from the axis. So this is your y equals 1 plus secant x, but we don't, which would have been the radius if we were rotating around that x-axis, but we're not, right? We're rotating around this line, so our inner radius, the way I would think about it is you want this, yes, that's confusing, right? So this whole thing is y. For our radius, we just want this piece, right? So we want to subtract this bit, right? So if I want this piece, let me write it down. Here, can you guys see it? The inner radius is going to be, I would do y minus 1, right? The whole thing minus this piece is going to give me this piece, right? This piece is just 1. So that y is 1 plus secant of x. So in fact, if we really want, we can write those here. And then this simplifies. So you might just try to remember, oh, I just take the function and I subtract the thing. I think it's, yeah, I mean, yes, but if your line is down here, you're actually adding it. If you're down here and you're rotating upwards, which you can do too, I mean, it might look different. And then from the x, from the y, it looks different. So when you're rotating around, I'm saying if we're rotating around a line, x equals something, so we're going like this and we're integrating with respect to y. We'll do one in the next video. I just draw it and figure it out because 2 squared, why do I have 2 squared? I could have written 4. That's what I do. Because I can't remember all those things. Like, I can't remember it as a rule. It's easier for me to kind of graphically figure it out than to try to remember more rules. Anyway, this integral is easy to do. This is, well, first of all, I lost my pi. Can't lose pi, right? So I'll just do real quick. Pi is going to be 4x. And remember, the derivative is tangent of secant squared. So this is tangent of x. And then you go ahead and you evaluate that from minus pi over 3 to pi over 3. And I'll spare you the gory details. The answer is 2 pi times 4 pi over 3. See, I did it. I just don't want to do all that arithmetic on the board. Is that. Okay, so that's the answer. 2 pi times 4 pi over 3 minus root 3. Which, as you can see, is a positive number. So it's good. And in fact, it's the right answer.